Hi there. Now in this question we're asked to find the binomial expansion of 3 plus 2x all to the power 5, simplifying the terms. And then in the next part, hence find the binomial expansion of 3 plus 2x all to the power 5 plus 3 minus 2x all to the power 5. Okay, so if you'd like to have a go at this and haven't done so already, just give you a moment to pause the video. Okay, welcome back then if you had a go. So first of all, to do this, the first part, what we need to be aware of is the binomial expansion, which I've just given you here in brief. If you've got a plus b all to the power n, it's identical to nc0, a to the power n, b to the power 0, plus nc1, a to the power n minus 1, b to the power 1, and so on. Now, for this example, when we're looking at 3 plus 2x to the power 5, a is the 3, b will be the 2x, and n will be the 5. And to get the values nc0, which in this example will be 5c0, 5c1, 5c2, and so on, you could either use your calculator to get the values, or you could use Pascal's triangle. If you're doing Pascal's triangle, you'd start off with 1 and then write 1, 1 either side, and then 1 and add together these two values, 2, 1, and you'd repeat this all the way down till we get to the line involving a 5 here. So you've got 1, 3, 3, 1, 1, 4, 6, 4, 1, and then this is the line we'll be interested in, 1, 5, 10, 10, 5, 1. These values here would correspond with our values in these positions here. Okay, so let's see how we can do this then. So for part 1, we've got 3 plus 2x, then 3 plus 2x all to the power 5. There's going to be quite a lot of terms here, so I doubt whether I'm going to fit them all on one line, so we might have to spread it out a bit. So this is going to be identical to nc0, so n would be the 5, so it would be 5c0, okay, or you could write in place of this the 1 here. And then it would be a to the power n, well a is the 3, so we've got 3 to the power 5. And then b to the power 0, b being the 2x, so it's 2x to the power 0. Next we would have this term here, 5c1, or you could write it just simply as 5, okay, 5c1. And then we've got a, which was 3, we reduce the power, it's down to 4, and we start to increase the b term, so that's 2x now to the power 1. Next term will be 5c2, or in place of 5c2 you could write the 10, and then it's going to be 3 to the power 3 and 2x to the power 2. Next term will be 5c3, which would be the 10 here. Then we would have 3 squared multiplied by 2x all to the power 3. And we are running out of room here, so we've got 2 more terms to write in, so we'll put plus, and now we have got, from 5c3, we've got 5c4, and then we've got 3 to the power 1, 2x to the power 4, and for the last term, we now have got 5c5, which will be the 1 here, and then it'll be 3 to the power 0, and then 2x all to the power 5. So if we let's just highlight these in green there, okay? So you can see those values coming through, the 1, 5, 10, 10, 5, and 1. So if you work this out, okay, let's take the first term, 5c0, which we know is 1, 3 to the power 5, 2x to the power 0, that's going to be 1. So we just got 3 to the power 5, and that turns out to be 243. 5c1 is going to be the 5. 5 times 3 to the power 4 times 2x. That turns out to be 810x. Okay, so plus 810x. 5c2 is the 10. We've got 3 cubed here is 27. Remember here you've got the 2 that is squared, so that's 4. So you've got essentially 10 times 27 times 4, and that will give you 1080, and that will be x squared. 5c3, well, that's going to be the 10 here. 3 squared is 9, 2 cubed, that's 8. Multiply all those together and you end up with 720. So you've got 720 x cubed. 2 more terms. 5c4 is the 5 times 3 times 2 to the power 4, which is 16 there. Times those all together and you should find you get 240. So you've got 240 x to the power 4. And the last term, well, that's going to be 1 for 5c5. 3 to 0 is 1, and you've got 2 to the power 5, which is 32. So you've got 32 x to the power 5. All right? Now, for part 2, okay, we've got to go on. It says, hence find the binomial expansion of 3 plus 2x all to the power 5 plus 3 minus 2x all to the power 5. So for this, we don't really have to expand everything like we did here. We can just pick up our results from here. Let's just put down what the question is first of all. We've got 3 plus 2x then, all to the power 5, plus 3 minus 2x, all to the power 5. Well, for the first term here, obviously we're going to have this expansion. So let's just put that one down. 243 plus 810x plus 1080 x squared plus 720 x cubed plus 240 x to the power 4, and finally plus 32 x to the power 5. Now to this we need to add this expansion. Now all we're doing is replacing the b with minus 2x. The a and the n stay exactly the same. So what we're going to have for this term in here would be minus 2x, but minus 2x to the power 0 is just going to be 1 anyway. So we're just going to get exactly the same value as we had here, 243. However, when we get to the second term here, this is going to say minus 2x to the power 1, which is going to be minus 2x. We're going to get negative 810 instead of plus 810. So that's going to be minus 810x. When we come on to this term here, the third term, minus 2x all squared is going to be positive. So this is going to be a positive term. Now you most probably can start to see what's going to be happening now. This term here is going to be minus 720 x cubed. And this one will be plus 240 x to the power 4. And this one minus 32 x to the power 5. So that when we add these two terms together, we're just going to get these two added, which is going to be 486. These two will cancel. These two added gives us plus 2160 x squared. These cancel. Adding these two together gives us plus 480 x to the power 4. And then the last two terms, well, they cancel out. So, hope that's been able to give you an idea how to do that question if it gave you any problems.